Besides the quotient, reciprocal, and Pythagorean identities, we also have what's called the double angle identities. Now, again, these are equations that have been proven to be true. We are not going to prove them to be true. You're just going to have to accept verbatim here that these are true equations. So, in your notes, pause the video and take a second and record these identities. These double angle identities you don't need to memorize. They will be given to you on quizzes, tests, and on the Regents exam. You just have to know when to use them and how to use them. Essentially, the gist of these equations is if you are taking some angle of rotation theta and doubling it, timesing it by 2, these equations will give you the sin of that double angle, the cos of that angle doubled, or the tan of that angle doubled. Let's take a look at what you're going to be expected to do with these identities. So given that cos theta is negative 5/13, we know since cos is negative, that means it can either be in quadrant 2 or quadrant 3. Now I'm going to tell us which quadrant we're going to be in. We're going to be doing theta is in between 90 degrees and 180 degrees, which essentially means quadrant 2. So we're going to go and start this just like we did long ago when we first started trig. If I rotate into quadrant, there's where my terminal side is, and now my reference angle theta will be right here, and my right triangle down to the x-axis so that the triangle encompasses the theta. And now we can label on our triangle what we know. If cos is negative 5/13, that means the adjacent is negative 5 and the hypotenuse is 13. Then you can use some Pythagorean theorem to figure out the opposite side. So this will be essentially 5 squared plus something squared equals the hypotenuse squared. So that'll be x squared equals 169 minus 25, and the square root of 144 is 12. So that's the opposite side, and it will be positive since it's going up. Sin is positive in the second quadrant. And now, of course, now that we know the three sides, now we could figure out sin, tan, cos, cot, and sec for that triangle. But we're going to figure out the double angles. So if I want to figure out sine of 2 theta, I'm going to be using that first identity in your notes, 2 sine cos. And I'm just going to get all my trig values right off this triangle. 2. The sin on this triangle is going to be opposite over hypotenuse, 12/13, and the cos was given to us, negative 5/13. And now it's just a matter of multiplying these three fractions together. In the numerators, 2 times 12 times negative 5 is negative 120. And in the denominators, 1 times 13 is 169. So that's how much sin of the angle doubled would be, is negative 120 over 169. Now, when I go to do cos 2 theta, we actually have a choice here on which equation to use, which identity to use. And I think of the three, I think I'm going to choose the first one, cos squared minus sine squared. So that means I need my cos value, which was negative 5/13, and I'm going to end up squaring that. And then I also need my sine value, which was 12/13, and I'm going to end up squaring that. So let's see, when I squared negative 5/13, that's going to be positive 25 over 169. Minus 12/13 squared, which will be 144 minus 169. Now when I go to subtract here, isn't this convenient? We have common denominators already. And when we subtract 25 minus 144, we get negative 119. And that would be the exact value of cos 2 theta. And lastly, if I want to use the formula for tan, no choice on this one. Tan 2 theta is equal to 2 tan over 1 minus tan squared. So in this formula, I'm going to need the tan off of our original triangle. So I'm going to do 2 tan. The original triangle tan is opposite over adjacent, so opposite would be 12. Adjacent would be negative 5. Over 1 minus that tan value squared. And now it's just a matter of working with some arithmetic here. When I multiply 2 times 12 over negative 5, that'll be 24 over negative 5. And on the bottom, I'm going to have 1 minus 12 over negative 5 squared will make 144 over 25. So that denominator, I will need a common denominator for 1 minus 144/25. So that's really going to be 25 over 25 minus 144 over 25. And now I can actually subtract these two fractions. 25 25ths, take away 144 25ths, will be negative 119 over 25. 24 over negative 5. Now we need to simplify this mess here with the complex fraction. Automatically I see these two negatives are going to divide out and make positives, so let's just get rid of those negatives. And now I'm going to go about this by getting a common denominator throughout. So if I multiply this top fraction by 5, that will give me 120 25ths over 119 25ths. And then the 25's cancel out. And voila, there is our tan of 2 theta, 120 over 119. And it's important to notice here that that answer for tan I could have gotten much easier just by doing the answer from sin 2 theta, negative 120 over 169, divided by the answer from cos 2 theta, negative 119 over 169. Because sin divided by cos is equal to tan, we would have ended up with 120 over 119.